The principle of pigging is very simple. Putting a special projectile down a pipeline, bringing it back again. But when I speak to companies that are trying to do it themselves, you sort of put your head in your hands and think, yeah, okay, that's not going to work, because there's a lot to take into account. There are tolerances, pig tolerances, length of lines, different pressures, different sequences, and so on.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor at Pumps and Systems magazine. Today, we're speaking with Peter Elgar, director of HPS Product Recovery Solutions. He's going to be talking with us about advanced liquid product recovery, also known as pigging, and its many benefits and uses. So, without any further ado, let's get into the episode. Welcome to the Pumps and Systems podcast. We really appreciate you being here. So I already asked you this before I started recording, but how are you doing today?
I'm great, Tom. It's great to be here. Thank you.
That's great. We're very glad to have you here. So today, we're going to be talking about pigging. But before we get into that, would you mind introducing yourself? So tell us who you are, what you do, anything you would like our listeners and viewers to know.
Okay, my name's Peter Elgar. I'm chairman at HPS. We're a UK company, and we specialize in advanced liquid product recovery technology, otherwise known as pigging technology.
And that is what we're going to be talking about today. So let's get into that main topic. So let's start out with the absolute basics. So what exactly is pigging? I'm assuming it has nothing to do with farming or anything like that.
No, it's got nothing to do with farming. It's an engineering product, basically. So very briefly, pigging is a method used by companies that transfer liquids through pipelines, and it saves them tens, sometimes hundreds of thousands of dollars, pounds, euros every year by recovering product, usually during batch changeovers, that would otherwise go to waste. So it's saving product that would literally go down the drain. And very briefly, it does this by putting in a special projectile called a pig. The pig has a very strong interference fit, and it's propelled through the line, and it literally pushes all this product out. And so it can be bottled, canned, processed, stored, whatever you're going to do with it. It's in exactly the same condition as the rest of the product being transferred.
So what kinds of companies use pigging, and why do they use it?
So fundamentally, increase yields, increase capacity, while improving efficiency. So it saves product, it saves water, saves chemicals, it makes changeovers a lot faster, it reduces contamination, cross-contamination risks. It's also good for the environment because it uses less energy. It saves creating a lot of effluent, so this effluent doesn't need to be treated, stored, disposed of, transported. It lowers companies' carbon footprints. It makes a lot of difference to companies. So the return on investment can be extremely high. Obviously, it depends on the value of the product, the length of pipelines and things like that. But yeah, it's becoming more and more popular, particularly as, the economic market tightens, costs are going up, consumers have less money to spend in their profits. Pigging is becoming more and more popular, I guess. We're dealing with more and more companies every year.
So you've just told us a lot of benefits of pigging. So are there any other benefits or unexpected ones that you've come across?
Yeah, I guess there are quite a few, actually. So the fundamental reason most companies use pigging is to recover product during batch changeovers, to stop this product going to waste so they can save it. And that's where the real payback is. But there are some more obscure benefits as well. So with the paint industry, for example, a lot of countries now have put restrictions on the use of biocides used in paint production. And because process pigging is fundamentally used in the food and beverage industries, in the hygienic industries, it can be also used in hygienic environments like paint production to prevent the use or save having to use these biocides. A quick example, one paint company we work with reduced product recalls by using pigging from 20% down to less than 1%. So that's a big win for them. Another example, a few years ago, we were working with a well-known beverage manufacturer. I'm not allowed to say who they were, but they were about to spend 5 million Australian dollars on building a new effluent plant. And then one of their engineers said, well, rather than spend all this money on a new effluent plant, why don't you not create the effluent in the first place? And so that was almost a $5 million win overnight. They didn't have to build the effluent plant because they weren't creating anywhere near the amount of effluent they were doing. Finally, another one, a bakery company. Now, the bakery product they were having to put to waste wasn't that expensive. And so, from terms of product recovery, there wasn't that much for them to gain. However, their storage tanks had started leaking. And they'd also been contacted by the local authority to say, you're not allowed to put any more of this product down the drain anymore. You've got to, they couldn't store it because they were at capacity. They couldn't put it down the drain. They were risking a large PR disaster or a big fine. So rather than having to dispose of or create lots of effluent, they saved the product, used it in their product rather than putting it down the drain.
So it sounds like it's useful in a lot of different industries, even ones you wouldn't really expect.
Yeah, we've food, beverages, confectionery, chocolate, industrial lubricants, paints, coatings. Pet food's a big one for us. Recently, we've been working with electric vehicle companies and their batteries. They have different types of slurries that go in their batteries, and obviously they want to recover them. But also, I guess that's another sort of obscure benefit of pigging. It's not just about recovery there. These battery fluids, they're slurries, and they cannot stay still. They have to be kept moving, otherwise they settle and they cause problems. So pigging can obviously keep the product moving. It's similar with chocolate as well. Sometimes there's a lot to gain with chocolate. The price of the cocoa bean is up and down all the time. Chocolate's actually a very expensive product, so they want to waste absolutely minimal amounts. They want to waste as little profit amount of chocolate as they can. So they use pigging anyway, but a big benefit is pigging. Again, chocolate has to be kept warm, has to be kept liquid. So by using pigging, you can keep it moving all the time.
Let's get a little more in depth now. So can you tell us like exactly how does pigging work? Give us the technical side of things.
Okay, so the principle of pigging is very simple. Putting a special projectile down a pipeline, bringing it back again. What could be easier? But it does get extremely complicated. So we've been doing pigging for 30 years, and we've probably made all the mistakes there is to make. But when I speak to companies that are trying to do it themselves, you sort of put your head in your hands and think, yeah, okay, that's not going to work because there's a lot to take into account. There are tolerances, pig tolerances, length of lines, different pressures, different sequences, and so on. But to get to the point, how does it work? Well, yeah, very briefly. So you have the pig itself, a special projectile. They don't look much, but there's an awful lot of work that goes into them. You have to have a method of launching the pig and receiving the pig and sending it back. You have to have a method of propelling the pig, which is usually done by compressed air, filtered compressed air, or sometimes water, sometimes carbon dioxide, sometimes nitrogen, depending on your requirements. So you propel the pig, and then, of course, you have to have a method of detection and control. So most pigging systems fully automated. So the pig has to be detected to tell the software, the PLC, the control system where the pig is, or indeed isn't at any one time. And then it can tell the various propellants to turn on, to turn off, valves to open, valves to close, various other parts of the process, and tell them what's happening and what they need to do next. That very briefly is pigging. And as I say, it gets very complicated because that's a typical one source to one destination. Sometimes you get one source or two or three sources to multiple destinations, different drop-off points, sometimes even different products and so on.
So the big question, why do you call it pigging?
Oh, I love that question. Okay. So there are various different theories and various different stories on pigging. So some people say it's called pig indication gauge or pig inspection gauge. I don't believe that because that sort of part of pigging has only been around fairly recently and it's been called pigging for a lot longer than that. Sometimes there's a very old English word called a pig, which refers to a slug of lead or pig of lead or something like that, which means a big chunk of metal. I don't buy that either. So my favorite story is that in the 1920s, 1930s, when the technology was very much in its infancy and it was used in oil and gas pipelines, there's a story that to scrape the residue off the inside of these, I think they were probably cast iron or corrugated iron lines, that people used to get a load of leather or cloth or paper and wrap them in barbed wire and literally push them down the line. And apparently it made a squealing noise like a pig. So it's called pigging.
That's a lot. I was afraid it was going to be like, and so they put a real live pig in there to scrape it through. So I'm glad that's
Yeah.
not the case.
I'm really glad that's not the case. No, no, it's nothing to do with the farm animal at all.
Okay. But yeah, I like that explanation best, I think. So I hope that's the true one. All right. So when does pigging make the most sense for companies? When should a company consider using it?
Okay, so companies benefit most from liquid product recovery or pigging technology when they have one or more. It's usually a combination of these issues. So they've got a high product cost, or they're doing multiple batch changeovers. If they're getting contamination or product cross-contamination risks, well, they've got long pipeline lengths, because if you think about it, the longer the pipeline or the wider diameter of the pipeline, the more product there is in there. So the more there is to recover by using pigging, and the less that will go to waste. And that's a similar thing with the changeovers as well. So the more changeovers to do, the more product you're going to waste. If they're using excessive water, now not every product uses or process uses water flush, but a lot do. And if they're doing long water flushes, then pigging will save that, because there's hardly any product left in the pipe, so they don't have to flush it so much. And also what we often find with flushing when people aren't pigging is the operators will have the very best intentions, but what they'll do is over flush, because they'll spend too long flushing because they want to make sure every last drop of product is out. But the downside of this is they're using too much water and it's taking a lot of time. Pigging can also save cleaning agents as well, again, because it makes the CIP process, the changeover process, a lot quicker, because there's hardly any product left in the line after pigging, barely a trace. They can save on cleaning agents as well as the flush water as well. If they've got high waste disposal costs, because obviously pigging saves on all this effluent, so it saves on having to treat, dispose, transport all this effluent, because you're not creating it anymore. And again, pigging lowers the carbon footprint, because pigging saves a lot of energy, particularly when there's heat involved, heating product, heating CIP fluids, heating water sometimes for the flush. It helps lower carbon footprint. It generally increases efficiency. And then, of course, there's effluent restrictions. If you restricted on the amount of effluent that you can use or you can transport or create, or certainly stick down the drain, pigging can help with that. Pigging goes a long way to helping companies with environmental targets. In fact, particularly in the last, if companies used to contact us 5, 10 years ago, it was all about the efficiency gains, the productivity gains, the capacity, the yield increases, and so on, and basically the profit. But now it's a lot of companies are also contacting us about the environmental benefits of pigging, because it saves water, saves energy, saves effluent, and so on. And then there are the more obscure things, such as, for example, product aeration, product foaming, products such as shampoos and soaps. So they tend to foam in the line, and there are ways using what's called a double pig system that you can prevent this. And similar with products like wine that can't come into contact with air. Again, pigging can help prevent this to process your line.
So we touched on this a little bit, but can you tell me more about how exactly the pig moves through the pipelines? You mentioned that the pig does not propel itself. What exactly happens there?
Okay, so depending on your process, the pig has to move somehow. So it's usually propelled by filtered compressed air, clean compressed air. Sometimes it's propelled by water. Now, not every product can use water. Not every process can use water, but a lot can. And the benefits of using water to push or propel the pig, it's very controllable. So you can pump it very precisely, whereas compressed air is a bit more, less controllable, let's say. Also, a benefit of using water to pump or propel the pig is that it's effectively providing an initial rinse. So you're rinsing and pushing the pig at the same time. And then again, depending on the product, carbon dioxide is often used because certain products can't come into contact with air, and carbon dioxide is useful for that. Sometimes nitrogen is used. It depends on the product, it depends on the process, but the most common ones are filtered compressed air by far, water, carbon dioxide, and nitrogen. Sometimes the pig is even propelled by the next product, which is fantastic, because it means changeover is effectively instant. You're going from one product to another straight away. Now, again, that is quite rare, because pigging will typically recover 99.5% of the product, but that still means there's a trace of the product left. So propelling with the next product is fine if the products are very similar color, similar scent, similar fragrance, similar texture, and so on. So you can get away with it with, say, certain types of paints, certain types of personal care products, home care products, and so on. You wouldn't get away with it with very different products, such as different types of food stuff and so on.
So, what happens when a pig gets to a bend or to the end of the line?
Yeah, this is a common misconception. So when a pig gets to a bend, now all pigs are different, so there's lots of different designs of pigs, but the majority of pigs will go around it. It's simple as that. But yeah, generally, when a pig gets to a bend, it'll simply go around it. Now, when it gets to the end of the line, there's different things that happen, depends on the design of the pigging system. But the vast majority of systems are fully automated, closed systems. So the only time you'd access the pig would be for maintenance or inspection. So very rarely indeed, maybe once a month, just to check things are okay. So when it gets to the end of the line, it's sent back again. So sometimes the pig will be propelled by water, get to the end of the line, and then it's sent back by air because air's very fast. Sometimes it'll just be propelled by air, get rid of all the product or send all the product to its packing, storage, bottling, canning, whatever, and then get sent back again to its launch housing receive station. Then they're usually held offline in receive station so the transfer process can go ahead as normal.
Let's talk a little more about tracking the pig. So, how do you know where it is? What methods are used to track it while it's moving along?
Yeah, a very important point there. Thanks. Yeah, pigs are detectable because the pigging systems are automated, or the vast majority of pigging systems are very automated. So pigs have to be detectable. So most pigs contain some sort of magnet. So there can be a flexible magnetic core, which are the safest. Some pigs contain solid magnets. Some pigs contain uh, granulated iron, so they can be detected. And then you have the pig detection systems. Now, these can be very basic detection systems, such as reed switches, or they can be more advanced ones, such as there's a system called an Accutect, which will send a special stretch signal to the control software, the PLC, the SCADA system, and so on, to say this is where the pig is, or indeed this is where the pig isn't. So you usually have a detection system by the launch housing, by the receive housing, by any drop-off points, and so on.
Generally, about how much pressure does it take to move a pig through the line?
Yeah, another great question, because I often show people a pig with a piece of pipeline, and they try and push the pig through the line, and it's really difficult to push it through the hand. But if you think about it in practice, the pig has to go somewhere. Now, it is a very tight interference fit. It has to be to make sure it recovers the high amounts of product that it does. But then again, in a closed system, the pig has got to go somewhere if it's got a pressure behind it. So typically, the pressure required to propel a pig is around the same pressure that you would pump your product at. So if you're pumping your product at 2, 3, 4, 5 bar, that's around about what you would propel the pig at. Sometimes a little higher, sometimes even a little lower, but it's nothing much around that. And that's a good rule of thumb.
And can you send more than one pig through the line at a time, or is it like a one pig sort of thing?
Yeah, the most common systems are what we call single pig systems, where you literally send the pig in, gets the product out, you send it back again. But there are more complicated systems. So there's what I call the dual pig system, which I mentioned earlier, which prevents it's basically the sequence of the pigs, if you like. You put one pig in, then the product, and another pig in, and that way it prevents the product from coming into contact with air. It's down to a special sequence. And then there's what's called the dual pig system, which I really like. And that's where there's a slug of cleaning fluid or water held in between two pigs. And the two pigs are propelled along. So it's basically cleaning, sanitizing, washing out as it goes along. And then this water can be changed when the pigs reach their destinations, and then they're sent back again. So yeah, sometimes it's sent with CIP fluid, and then sometimes sent back with water. It's a great system used a lot in the paint industry as well as some others as
Mm.
well.
So, are there different types of pigs for different types of products, or do they all use basically the same type?
There's lots of different shapes and sizes of pigs on the market. There's cylindrical pigs, finned pigs, dog bone shaped pigs, all sorts of different pigs. And there's different pigs for different products. So with the HPS system, for example, by far the most common pig is our blue pig, which is made from FDA materials, and it's used widely in food and beverages. But because it's hygienic and you know, designed for use in food and beverages, it's often used for paints, coatings, some home care products, some personal care products as well. And that's by far the most common usage of the pig. However, when you get special chemicals, certain solvents and so on, you need a pig that's resistant to those materials. And then when you get to really aggressive chemicals, you need another type of pig again. So the most common pig is the the FDA material approved pig, which is used in all sorts of different applications, but there are specialist pig for other products as well.
So, about how long does a pig last before you have to change it out, get a new one?
I get asked that a lot, and basically it depends because every process is different. There are different lengths of line, different numbers of bends, different operating temperatures, and of course there's the product as well. So with a product like an industrial lubricant, it doesn't really wear the pig at all. So the pigs tend to last forever or a very long time indeed. Things certain like hand lotions and things like that, things that are very lubricating, the pig lasts a very long time. But then you get a product like toothpaste, which is abrasive, it's supposed to be. And of course, that abrades the pig as well. So the pig won't last as long. So it depends on a lot of factors, the main factor being the type of product, but also the operating temperature, the length of pipe, how long it's used, and so on, how many bends there are. But basically, as a rule of thumb, and I'm not supposed to say this, but I will, a pig will last roughly about 18 miles. But there is a big, it depends with that.
That's all we can ask for. All right. So, are there any liquids that cannot be pigged?
We've done everything from really thick pet foods to fatty products to we've even pigged an adhesive, a very thick, viscous, horrible chemical that's used to stick the wings of airplanes onto airplane fuselages. Very horrible chemical. They said you can't pig that. As long as you can transfer it, as long as you can pump it through a pipeline, we can pig it. So there's very, very few products that can't be pigged. It does get more complex when you get to dry materials, powders, that sort of thing. That's a different. But when it comes to liquids, there's very, very few products that can't be pigged.
Okay. Though I imagine you need a pretty tough pig for the airplane glue.
Yeah, that was a specialist pig, but the glue goes through the line, so it can be pushed through the line by a pig as well.
And does pigging work with clean in place systems?
It go absolutely hand in hand with cleaning place systems. Now, there's a slight common misconception because pigging is all about product recovery. That's the fundamental, the number one objective for using pigging for the vast majority of companies is to recover product. But sometimes people mistakenly say pigging's for cleaning. Well, it sort of is, but technically that's not correct because it won't sanitize because even though it recovers basically all the product in the line bar a trace, there is a trace there. So particularly with foodstuffs, you will still need to do a sanitation, and that's where CIP comes in. But because there's hardly any product left in the line after pigging, it makes the CIP process a lot quicker because there's less product. So there's less. You need less water flush because there's hardly any water product left in the pipe, so you can flush it away very quickly. Again, you need less CIP chemicals and less water flush again. So it goes absolutely hand in hand with pigging. Pigging will usually speed up the CIP process and make it a lot more efficient.
All right. So before we wrap up, do you have anything else you'd like to share or any final thoughts you'd like to leave us with?
Yeah, often I speak to a lot of people in a lot of industries that have looked at pigging in the past. And one thing that comes up maybe once a month or so is they'll say that pigging is dangerous. And I'll say, well, why is pigging dangerous? And I hear some absolute horror stories because pigs falling out, magnets flying out of lines being blown apart, that put people off, and quite rightly put people off pigging. Now, the principle of pigging is very simple, but one of the problems is because it's simple, then people think they can do it themselves. Now, we've been in this game for 30 years, and they say there is a lot you need to take into consideration, particularly on the safety front. These are pressurized systems. The pigs move very fast. They contain magnets sometimes. You've got to get it right. You can't risk it. So safety, there are many safety features you can build in, interlocks, pressure, automatic depressurization routines, all sorts of things, but you must build these in. And that's why it's very important, in my opinion, that people should never try and build a pigging system themselves. There are companies out there that will sell you a box of bits and say, there you go, build your own pigging system. There is an awful lot to take into account, and it's very important. So I strongly recommend whoever company you use a pigging specialist to make sure firstly that the systems are going to work, but work effectively, and more importantly, work safely.
So not a sort of like DIY, watch a YouTube video sort of situation here.
Unfortunately, I've come across people doing that, And
Yeah.
I've heard some real horror stories, and it breaks my heart because pigging is a great technology, but you've got to do it right and you've got to do it properly. With increased costs of raw materials, supply chain issues, fluctuating prices, it's becoming more and more popular because it makes companies more efficient. And the return on investment, I mean, it's not that difficult to work out the return on investment of a pigging system. I think it's worth doing for a lot of companies. And a lot of companies don't know about pigging, that there are specialist companies out there that can really look into it for you and make you a bespoke solution. So, yeah, I think if you transfer product through pipelines, you transfer liquids through pipelines, it's really worth having a look at pigging and seeing what it can do to you and seeing if there is a business case for you.
All right. Well, thank you so much for being here and taking the time to talk with us. We really appreciate it.
Thanks, Tom. Great to speak to you.
Huge thanks to Peter for taking the time to speak with us today about pigging technology. If you're listening to the podcast and would like the chance to watch it, head over to our YouTube page to watch the full video version. That's going to do it for this episode. Thank you so much for listening or watching, and we will see you next time.